Hello everyone, in this video I'm going to discuss the example for differentiation. Kindly refers to the question. So given we have the function fx where we have the piecewise function. So my suggestion would be kindly illustrate the situation in a real number line. So x less than 2 we have the function x squared minus 3. X is equals to 2 where we have the function square root of x minus 1. So here we have the number line. Show whether the fx is differentiable at x is equals to 2. So kindly refers to the formula. So limit when x approaching a for the function fx minus the fa over x minus a. So that would be the formula. So kindly focus on the left hand side. Limit when x approaching 2 from the left. For the function fx, we have x squared minus the 3 minus the f2. Substitute into this part, 2 minus 1, we have the 1 over x minus the 2. So based on the situation, limit when x approaching 2 from the left, we have x squared minus the 4 over x minus 2. If we substitute and we will have indeterminate form, so for this case, my strategy will be factorize the situation. So where we will have x minus the 2, x plus with the 2 over x minus the 2. Simplify, limit when x approaching 2 from the left, and we will have x plus with the 2. So for the situation, and we will have limit when x approaching 2 from the left for the function fx minus the 1 over x minus the 2, the value of y will be approaching 4. Or we can say f prime bracket 2 from the left, the value of y will be approaching 4. Next, focus on the right hand side. Limit when x approaching 2 from the right. For the function, we have the square root x minus 1 minus the 1 for the f2. So based on the situation, if we substitute and we will have indeterminate form, so the strategy for this case would be multiply by the conjugate. So do remember, only expand for one part. Focus on the numerator. Limit when x approaching 2 from the right. Expand the numerator, so we can make use of the a squared minus b squared. So x minus 1 minus, we have the 1 over x minus 2 bracket multiply with the square root of x minus 1 plus with the 1. So limit when x approaching 2 from the right, and we have x minus 2 over x minus 2 multiply with the square root of x minus 1 plus with the 1. Simplify, and we will have the situation 1 over the square root of x minus 1 plus with the 1. So if we substitute the value 2, and we will have the value of y approaching 1 over 2. Or we can say f prime bracket 2 from the right, and we have the value 1 over 2. So based on the situation, f prime 2 from the left, is it equals to f prime 2 from the right? So the answer is not the same. So from here we can say that fx is not differentiable at x is equals to 2. Next, kindly refers to b. Differentiate the y with respect to x. Give your answer in the simplest form. So in here, my suggestion would be make use of the product rule, where we have y prime is equals to, so let's say here we have u and then this one v. So where we have v u prime plus u v prime. So let's begin. We have y is equals to, we have the x squared plus the 1 multiplied with 1 minus x squared power of 1 over 2. And we denoted it as a u as a v. So dy dx, where we have v 1 minus x squared bracket 1 over 2. Differentiate the u, so we will have 2x. Plus, focus on the u, so where we have x squared plus the 1. Next, differentiate the v. So let's begin with the external function, where we have 1 over 2 bracket 1 minus x squared to the power of negative 1 over 2. Differentiate the internal function, and we have negative 2x. Continue. Try to simplify the situation given. So here we will have the situation 2x bracket 1 minus x squared. So for this case, we can simplify. So we have negative we have x multiplied with the x squared plus the 1 over, we have the square root of 1 minus x squared. Kindly equate the denominator. So rewrite the situation. We have the 2x bracket 1 minus x squared multiplied by the situation. So here we will have square root 1 minus x squared over square root 1 minus x squared. Minus, we have x multiplied with the x squared plus the 1 over the square root of 1 minus x squared. So now we have the same denominator, so we can combine the situation. So here we have 2x multiplied with 1 minus x squared minus with, we have the x cubed minus with the x over, we have the square root of 1 minus x squared. Kindly expand, we have 2x minus 2x cubed minus the x cubed minus the x over, we have the square root 1 minus x squared. So continue. So here we have x minus the 3x cubed over the square root of 1 minus x squared. So here we have the dy dx, or differentiate the y with respect to x.